This is much more like a problem that you could expect to see on a test, because this problem only has two linear factors in its denominator. So first, let's go ahead and get it set up. Notice that I went ahead and factored that denominator for you. We have linear factors, nothing is repeated. We're going to stick a over the x minus 3 and a b over the x plus 2. Once we have that, the next step is for us to go in and clear out our denominators. I'm kind of ignoring that. I'm only working with those two sides of this equation. We're going to multiply everything by the common denominator on the left. You will always be multiplying everything by this denominator here. Okay? So multiplying by x minus 3 times x plus 2 there, multiplying by x minus 3 times x plus 2 there, multiplying by x minus 3 times x plus 2 here. X minus 3 cancels, x plus 2 cancels. Everything should always cancel out completely on the left side. And I'm just left with the numerator of x plus 7. That should always be the case. On the right side, when you multiply the fraction with the a by the x minus 3 times x plus 2, the x minus 3's will cancel and the x plus 2 will stay. In the second fraction, when you multiply the b term by that product, the x plus 2's will cancel and the x minus 3's will stay. So this is what we have now. Now we need to go in and distribute. This is the point where we start completely simplifying out the right side so we can start equating coefficients. So I have x plus 7 is equal to ax plus 2a plus bx minus 3b. I'm going to be grouping my terms together, so I'm going to write my x terms right next to each other, and then I'm going to write the terms that do not have an x right next to each other, so I really only move that term over there just to put my x terms together. And I do that because once the x terms are together, it's easier to see what you're left with when you pull that x out, which in this case is simply a plus b. You don't do anything with those constant terms, right? Just leave those constant terms, the terms that don't have an x, leave them together at the end. Now we're ready to start equating coefficients. So we're going to look and see what is the number in front of x on the left side of the equation. It's a 1. You don't see it because it's a 1. Don't tell me it's 0. If it was 0, there would be no x. And the number in front of x on the right side of the equation is a plus b. So it must be that 1 is equal to a plus b. The number that has no coefficient, or has no variable on the left side of the equation is 7, and the number that has no variable on the right side of the equation is 2a minus 3b. So it must be that 7 is equal to 2a minus 3b. You see what I mean? This is a much simpler system of equations to solve. I'm going to solve this by addition. Let's solve this by addition. You could quickly use substitution too, right? Because you can take that first equation and solve for either a or b. I'm going to choose to eliminate a, so I'm going to multiply the first equation by negative 2. So then I will have multiply everything in the equation by negative 2. Then I will have negative 2 equals negative 2a plus b. Yep, I literally just said multiply everything in the equation by negative 2, and I did not. Multiply the b by a negative 2 as well. Okay, I'm going to keep the second equation the same because now I am set up to eliminate a. When I add my equations together, negative 2 plus 7 is a positive 5. Negative 2a and 2a cancel each other out. Negative 2b and negative 3b make a negative 5b. Now we can divide both sides of this equation by negative 5 to see that b is equal to negative 1. Now that we know that b is equal to negative 1, we can choose either of these equations to plug that into to solve for a. I'm going to choose to use the first equation, which is 1 is equal to a plus b, but I now know that b is negative 1. So now I'm just going to add 1 to both sides of this equation to see that a is equal to 2. So now that we know the value of a and we know the value of b, we can fill this out, right? So our partial fraction decomposition is 2 over x minus 3, that's the a over x minus 3, plus negative 1 over x plus 2. That's our b over x plus 2. So in other words, If we had this problem in lesson 4 to add those two functions, we would have added them together and our answer would have been this. Or this, either one, because those are the same thing, okay? So we're going backwards. We're breaking it apart.